Hi there, this is Math 7, Unit 6, Lesson 19, Expanding and Factoring today. We're going to use the distributive property to write expressions in different ways. So first of all, let's have a little talk about parentheses and kind of order operations. And find the value of each expression mentally. So when I look at this first one, I recognize that I need to do multiplication first. So I'm going to do 3 times 4, which gets me to 12. And then 12 plus 2 gets me to 14. When I look at this one, because I have something inside the parentheses, I'm going to take care of that part first. 2 plus 3 gets me 5, right? And then I can multiply 5 to the 4 to get me with a 20 there. Over here, again, order operation says multiply first, so 3 times 4 is still going to be 12. So then I end up with something that says 2 minus 12. I'm going to rewrite it real quick just so I can take a look at it so I don't get too confused. So 2 minus 12 is like 2, and I'm adding at the opposite, negative 12. So I end up at a negative 10 is what I have left there. Here, I'm going to add those together to come up with a 7. So I have 2 minus 7, or I could say 2 adding a negative 7. And so when I put those together, I have a total of negative 5 for my solution there. So it's important to take a look at parentheses and know how order operations work so you know what's going on. Today's lesson here is on factoring and expanding with negative numbers. And it's a really important skill for you to learn how to master and do regularly on your own. And so we have a lot of practice with this today. And this may be the first time you're really seeing this, but the idea is that if we know how to distribute something, that means if we know how to take a negative 3 and multiply it into a 5 minus 2y, when I take this expression right here and I distribute, I do negative 3 times 5, which gives me that negative 15, and a negative 3 times a negative 2y gives me the positive 6y. And so I know that when I put that together, I could rewrite this whole thing as also being negative 15 plus 6y, and these are two equivalent expressions. They are the same thing. I can do it here by practicing with this box here to help me understand, like with the area grid, how this works. 5 times a becomes 5a, right? And 5 times negative 6 is a negative 30. So if I had to write this out over here expanded, this is the expanded way, I would take the 5 times a minus 6 and rewrite this as 5a minus 30, because that's what I see here is expanded. So this way is 5 times what I have right here, a minus 6. And then when I distribute it, I end up expanding or stretching it out. But what's really cool is about going the opposite way. I can do the distributive method in the opposite direction in order to kind of pull things apart. And to do that, what I look at is I look inside the box here and say, well, what do both boxes have in common? We kind of call this a common factor. So in this case, I recognize that they have different letters. I can't do anything about the letters, but I notice that they're both even numbers, a 6 and a negative 2. And so in this case, they've already helped you out by saying I could take a 2 out of each of these. And so to think to yourself, 6 divided by 2 is what? That's going to be 3. I could think the other way and think 2 times what number can get me to 6? Again, it's 2 times 3. The a I don't want to forget about, so I'm going to include it here. And so you can see if I multiply 3a times 2, I end up with 6a. Over here, I'm going to take a 2 out, and so negative 2 divided by 2, negative 2 divided by 2 equals what? It equals a negative 1. I could write a negative 1 right here if it helps you see it better, but I'm also going to keep the b, so I have negative 1b, or just simply negative b. So, as written as a factored way, I have a 2 on the outside. Okay, this is my 6a minus 2b. I have a 2 on the outside, and that's going to multiply together with 3a here, and I can just write minus b right there. So we're going to do this same idea all the way down with all these other ones just to practice it out. If it helps you to write it with the boxes, you certainly can. If you start to see it a little better, that's okay too. So let's talk these through. So I'm going to do the ones that are factored and make them expanded first. So negative 4 times a positive 2w is going to become a negative 8w. Now negative 4 times a negative 5 is going to be a positive 20, and I include the z, so positive 20z. On the next one, I'm going to distribute the negative. Even though there's not a number there, I could pretend it's like a negative 1 if it helps you kind of visually see it a little better. It's just a negative there. So negative 1 times a 2x becomes a negative 2x, and a negative times a negative 3 becomes a positive 3y. When I look at this one here, now I'm going to have to go the opposite direction. I'm going to distribute backwards a little bit, right? So let's say I take my box like this, and I know I have a 20x, I have a minus 10y, and I have a 15z. What number or letter can I take out of all three of these? And in my case here, I recognize I could probably take a 5 out of everything, because these are all factors of 5. 5 times what gets you to 20? 5 times 4. So we would include the x to make it 4x. 5 times what number gets you to negative 10? That'd be a negative 2, and keep the y with it. And over here, 5 times what gets you to 15? That'd be a positive 3z. So in terms of rewriting this factored, I have a 5 on the outside, and inside the parentheses, I would have this group of numbers. I'd have 4x minus 2y plus 3z. For this one, we're going to expand. K times 4 is 4k, and then k times negative 17 is negative 17k. Could I group them together? Yeah, I could eventually, but right now it just wants you to practice expanding and then working the other way. All right, on this one here I have really just two boxes, right? I have 10a and I have a minus 13a. There's no number that goes into both 10 and 13, but they both do have an a, and I could take an a out of that with no problem. If I take an a out, what do I have left? I just have 10. 10 times a is 10a. And over here, what I have left over here, I have a negative 13. So when I rewrite this, I have a on the outside, and what goes inside the parentheses is here, 10 minus 13. So that's the factored way. For this next one, we're going to multiply negative 2x times a 3y for a negative 6xy. And then a negative times a negative is going to be a positive, and this would be a 2xz. Like so. On this next one, let's see if I can do without the boxes here with you. They each have a b and a b and a b. They all have the b in common, so I can factor a b out of the whole thing. What's left of this term is an a. What's left here is a minus c. And what's left here is a minus 3d. And finally, this last one, negative x times 3y becomes negative 3xy. Negative x times negative z becomes a positive xz, and negative x times 4w becomes a negative 4xw. Alrighty, and that's it there. So that's the idea between factoring and expanding, and that really is what today's lesson's about, which is take some practice. You will continue to use this skill all the way through the rest of your math classes, all the way through high school. In fact, I just did one of these lessons the other day for a Math 2 course. So, in summary, here's our point today. You can use properties of operations in different ways to rewrite expressions and create equivalent expressions. We can use the distributive property we've already seen to expand an expression, and we can also use distributive property in the other direction to factor an expression out. So it works both ways, right? So we can take something like this as 12x minus 8, and we can factor out. When we take a look at this, we see that what do they both have in common? There's a 4 that they both have in common. I can take a 4 out of there and a 4 out of there. And I ask myself then, 4 times what gets me to 12? 4 times 3. I keep the x with it. And then 4 times what gets me to negative 8? It'd be 4 times a negative 2. So in factored form, this becomes 4 times 3x minus 2. But that is equivalent to this thing, which is 12x minus 8. Those are the same expressions. They are equivalent to one another. And that really is what today's lesson is all about. All right, let's take a look at your homework. So do that, press pause, and come back and check it out. Okay, the first one, we're going to expand to write an equivalent expression. So here we go. So first we have -1/4 times a -8. So if you think about this and go the long way, this becomes a negative times negative is a positive. 8 times 1 is 8/4, and we have the x still. Here we have a negative times a positive, so we'll have a negative answer. And we have 12/4, and that's a y. I can reduce 8/4 becomes 2x minus 12/4 becomes 3y. So that's my first one. And here we're going to factor out to write an equivalent. So what do they both have in common? I have a 36 and 16. And this is where it is important to know your math facts. What do they both have in common? Sometimes it's good just to think, well, if you don't know them, if they're both even, you could at least pull a 2 out of both of them and that'd be okay. But in this case, it'd be better to take out a 4. Why a 4? Well, because I know that 4 times 9 gets me 36. I also know that 4 times 4 gets me 16. So if I have to factor something out, I'm going to take a 4 out of both of them, and I'm going to be left on this side. 4 times what gets me 36? 9, and we'll leave an a. And how do I get to negative 16 from 4? I multiply by a -4. So that's how I factor that out there. This next one is really a place for you to write and explain your own thinking for how this factoring and expanding works, okay? So I'm not going to write a whole lot here for you. I'll talk it through with you, but you have to explain it in your own words in a way it makes sense to you. It says that Lynn missed math class on the day they worked on expanding and factoring, so she missed today's lesson. Kieran is helping Lynn catch up. Lynn understands that expanding is using distributed property. So she gets expanding is distributed property. But she doesn't understand what factoring is and why it works. How can Kieran explain factoring to Lynn? So factoring is doing what? It's kind of the opposite. It's using distributed property in the other direction. It's where you're looking for common factors, right? And that's the key thing there, to keep that in mind. So when Lynn asks Kieran how the diagrams with boxes help with factoring, what should she tell Lynn about the boxes? Well, whatever you have in the boxes, right? You have these boxes here. We're going to take something out of each box and put it on the outside. And that thing is what we're factoring out in order to figure out what's going to go here and here. So what's in the box, inside the box becomes the product of these things multiplied together. But what is outside is what you can factor out. And that's how that typically works there. And so that's something you can write in your own words. So Lynn then asked Kieran to help her factor this expression out. How can she use this example to show that? So again, she could find out what they have in common. She can do it with a box, whatever works. Let's do it with the box method, just to keep a model for you in place. And we have 3 different terms. We have -4xy, we have -12xz, and we have +20xw. So for each of these, I noticed that they have 4, 12, and 20. 4 goes into each of those terms. I also noticed that they each have an x, an x, and an x, so I can take an x out of all of them. So looking here, I have a 4x going in. What's left over here, 4 times what number will give me a -4? That would be a -1, okay? And then what's remaining? I still have a y. So I could just write it as -y, and that would be acceptable. We could write -y above there. So 4x times a -y is going to give you -4xy. All right, 4 times what number gives you -12? We would say -3. We already took the x out, so I still have a z right there. And then 4 times 5 gets you to 20. We already took the x out, so we're left with a w there. So if she was to rewrite this in factored form, we'd put the 4x on the outside of the parentheses, and on the inside we would say we have this right there, -y minus 3z plus 5w. And those all go together like so. Okay, and that's the idea. Okay, this next one. They've already put the a and b here, and they're saying there's something we can do with the numbers to factor them out. If you know much about quarters, we could say that there are 3 quarters here and 1 quarter there, which means we could take a 25 out of both of them, which leaves me 25 times 3 gets me to 75, right? 3a plus the b. And that's my factoring there. All right, and our next problem here, we have Elena making her favorite shades of purple paint by mixing 3 cups of blue, 1.5 cups of red, and 1/2 cup of white. So let's just jot this down on this side of the page so we can see it all together real quick. So we have 3 cups of blue and 1.5 of red, and 1/2 cup of white. So that's what she has here. That's her ratio she uses to make the paint. So in all, if we added this up, she has 3, 4, 5. So this ratio makes 5 cups of paint, purple paint, we should say. Now Elena has 2/3 cup of white paint. Assuming she has enough red and blue, how much purple paint can she make? That's our question here. So we're basically going to set up a little proportion to solve this one. All right, we know that this ratio of paint makes 5 cups. So in terms of what she has, we know that she has 2/3 white paint. Well, for the ratio, you have to have 1/2 cup of white in order to make 5 cups of paint. Okay, so that's going to be true. Now, we know that she has currently 2/3 cup of white paint, and the question is, how much purple paint can she make? So we don't know. So 5 cups of purple is what we're making. So that becomes our ratio. 1/2 white over 5 cups of purple is equal to 2/3 white over I don't know how much purple. We could then cross multiply. So we have 1/2 x is equal to 5 times 2/3, which is 10/3 there. To solve for x, I'll multiply both sides by the reciprocal, 2 over 1. So x is going to be equal to 20 over 3. So how many cups of purple paint can she make? 20/3 cups of paint. If I want to write that as a mixed number, 3 goes in there 6 times, so I have 6 2/3 cups of paint. Purple paint is what she can make if she has 2/3 white. Now we're going to use this same number though to then figure out how much blue paint and red paint she'll need to mix with the 2/3 cup of white. So knowing that the ratio blue, so 3 blue works for 5 cups of purple, and we don't know how much blue she has, but we know she's going to make 20 1/3 cups of purple. We can now solve this for purple by cross multiplying. All right, so that becomes 3 times 20 over 3 equals 5x. The 3's cancel, so you're left with 20 equals 5x. We divide both sides by 5, and 4 equals x. So this is going to be how much blue paint she's going to need there. And then when it comes to the red paint, same idea. The red paint, we know that she had 1.5 cups of red. So that's 3 over 2 red compared to 5 purple. And that's equal to, I don't know how much red, over 20 over 3 purple. So again, cross multiplying, we have 3 over 2 times 20 over 3 equals 5x. The 3's cancel. 20 divided by 2 is 10. So 10 equals 5x. Divide both sides by 5. And 2 equals x, so the amount of red paint that she's going to need. So we had to solve the first one to figure out how much paint she's going to make in total with her 2/3 of white, and then use that number within our new ratios to solve for how much red and blue you would need to combine with the white that she had. So it's a great problem, just a little bit long. All right. Okay, moving down to number 5. Number 5, we have 5 different equations for you to solve here. The first one really is, I think, the longest one. The rest are pretty straightforward. So to solve this first one, we have -1/8 d minus 4 equals -3/8 there. I'm going to add a 4 to both sides to make that go away. So I have -1/8 d equals 4 minus 3/8. All right, so that one might be a little trickier for you if you're not sure about 4 minus 3/8. It's going to end up being 3 and 5/8 is what I come up with there. Okay, so how would you do that if you're not sure? Looking for some space here. If I did 4 minus 3/8, I need a common denominator, right? So to make this a common denominator, I can make this into 32 over 8, because 32 divided by 8 is 4. So 32 divided by 8 minus 3 divided by 8 becomes 29 over 8. And 8 goes into there 3 times with 5 left over for 3 and 5/8. So a little bit lengthy process, but you can get to that point. Now to solve for D, I'm going to go ahead and combine this back up, so this becomes negative 1/8 D equals 29 over 8. I'm going to multiply by the reciprocal, negative 8 over 1 times negative, let's try 8 over 1. Yep. So this leaves me with a positive D equals a negative 29, because those cancel out, and I'm left with just a negative 29. So A is negative 29. No problem there. That's the most complicated one. Let's take a look at B. We have negative 1/4 M plus 5 equals 16. We're going to subtract 5, so negative 1/4 M equals 11. Multiply by the reciprocal, and M equals negative 44. This next one, we have 10b plus negative 45 equals negative 43. So here I have a negative 45, so I'm going to add 45 to both sides. That goes away, so I'm left with 10b equals negative 43, and positive 45 leaves me with just 2. Divide both sides by 10, and b equals 1/5. If I reduce that down, I get 1/5 there. For D, let's see what space for D. We have negative 8 times y minus 1.25 equals 4. I'm going to divide both sides by negative 8. So that y minus 1.25 equals a negative 1/2. I can rewrite negative 1/2 as negative 0.5, because I have a decimal over here. And now I'm going to go ahead and add 1.25 to both sides, so that y equals 1.25 minus 0.5, which is going to be a positive 0.75. And then finally, this last one, 3.2 times s plus 10 equals 32. Divide both sides by 3.2. S plus 10 equals 10. Subtract 10, subtract 10. S equals 0. And that is a fine answer. It's a little strange, I know, probably to you, but that is an okay answer. Sorry. So those become my solutions and the steps. A little quick and messy there, I know, but you gotta just work it out. All right. All right, and our last one, I think it's our last one here. Yep. Last one, we have choices A, B, C, D. We also have choice E on my other side, which is x is greater than 5. And we have choice F, which is x is greater than negative 5. So let's set this up. We have negative 4x, and I'm going to make it equal to 20 to start with. Divide both sides by negative 4, so that x is equal to negative 5. That becomes my boundary, okay, my limit. So let's see which way the sign is going to go. Is x going to be less than negative 5, or is x going to be greater than negative 5? Okay, for a number greater than negative 5, I'm going to use 0, because it's just nice to use, right? So I'm going to do negative 4 times 0. Is that less than 20? This becomes 0. That's 20. That is a true statement. And because it's true, then this becomes my equation for my inequality. So I know I'm looking for things that are the same as x is greater than negative 5. It needs to be the same as that. So already I know f is going to work because it's exactly the same. This is x is greater than 5, so E is not going to work. This is x is less than negative 5, so D is not going to work. For this one here, 4x is less than negative 20. If I did 4x less than negative 20 and divided both sides by 4, that'd be x is less than negative 5. Again, I want x greater than, so C is not going to work. For this one, B, if I did 4x greater than negative 20 and divided both sides by 4, that gives me x is greater than negative 5, which is what I want, B. And in this one here, this one actually does work out, because if I do this right and I kind of plug a number in and try it out, I'm going to get something that's equivalent. Again, if I put a value in here for 0, is 0 less than 5? Yes, it is, and so it works. So A, B, and F are all good solutions for that problem right there. That's it, and we'll see you next time.